Welcome to episode 2 of Security Explained. Today we're digging into injection, the attack class behind decades of breaches, from classic SQL injection all the way to cross-site scripting. It all comes down to one idea: what happens when input you trusted as data quietly gets treated as code, and there's a single pattern that shuts the whole thing down. So let's start with the core problem. Your application takes input from a user and uses it to build something: a SQL query, a shell command, an HTML page. The moment that input gets treated as part of the instructions instead of as inert data, the attacker is no longer answering your prompt, they're writing your code. Every injection bug, no matter the flavor, is the same shape: data crossing the line into the code that processes it. Keep those two apart, and the entire attack class falls away. So here's the one-sentence definition worth memorizing. Injection happens when untrusted input gets interpreted as code, letting an attacker run their commands inside your system. The flavor changes with the interpreter: SQL, shell, LDAP, NoSQL, and on the front end, cross-site scripting, which is really just injection into the browser. But notice, they all share one fix family: separate the data from the instructions. That's the thread we'll keep pulling on. Let's pull on that thread with the classic example. The code here builds a SQL query by gluing the user's name straight into the string. So a normal input like Alice produces exactly the query you'd expect. But when the attacker types apostrophe or 1 equals 1, that input stops being data and becomes part of the logic. The where clause is now always true. Every user matches and the login is bypassed. And once you can rewrite the query, you can dump tables, drop them, or quietly add yourself as admin. The fix is almost anticlimactic. Instead of gluing the input into the query string, you send the SQL and the data on separate channels. The question mark is a placeholder, and the name gets bound as a pure value. Now that same apostrophe or 1 equals 1 payload is just a literal string. The database looks up, fails to find, and moves on. No interpretation, no logic change. That one discipline, placeholders, or a well-used ORM, closes the entire SQL injection class. And once you see that pattern, you start spotting it everywhere. Command injection is the same bug with a shell instead of a database. A stray semicolon turns your file name into RMRRF. NoSQL swaps strings for crafted JSON objects that smuggle operators past your query. LDAP, XPath, and server-side templates all play out the same way. Untrusted input ends up interpreted as code. Different targets, identical root cause, and, encouragingly, the same defense everywhere. Which brings us to XSS, the same pattern, but the interpreter is the browser instead of a server. The attacker doesn't run code on your machine. They get their JavaScript onto your page, and it executes inside your visitors' browsers, under their sessions. So the payload, stealing cookies, logging keystrokes, acting as the user, runs with the victim's full trust in your site. Your users become the execution environment. XSS comes in 3 shapes, and they differ mainly in how the payload reaches the browser. Stored means it lives on the server, a comment, a profile field, and every viewer gets served the same poison page. Reflected bounces off the server in a single response, usually through a crafted link a victim has to click. DOM-based never touches the server at all. Client-side JavaScript takes attacker-controlled input and writes it straight into the page. Stored is the one that scales. One injection, every visitor. The defense mirrors what we did with SQL. Keep data as data. When user input lands in the page, encode it so the browser treats it as text, not as markup to execute. The difference is one property. Inner HTML hands the string to the HTML parser, so a script tag runs. Text content inserts the same string as literal characters, so the tag just shows up on screen. Pair that with a content security policy header, and you've shut the door at 2 independent layers. It's worth lining these two up side by side because the symmetry tells the whole story. SQL injection targets your server and steals your data. XSS targets another user's browser and hijacks their session. One runs server-side, the other client-side. The fixes look different on the surface. Parameterize the query versus escape on output, but they're the same move. Keep untrusted input from being interpreted as code. Same disease, different organ. So, how do we actually defend against this? It starts with the move we keep coming back to: parameterize or escape so input never gets interpreted as code. Validation is your second line. Prefer allow lists because enumerating what's good is always safer than guessing what's bad. Then least privilege, so even if something slips through, the database user can't drop tables and the app can't spawn a shell. CSP and a WAF sit on top as backstops. The first layer should stop the attack. The rest are there for when it doesn't. And this is worth pausing on because filtering feels like the obvious fix. Strip out the word script. Reject suspicious characters, done, but block lists always leak. Attackers have mixed casing, URL encoding, HTML entities, Unicode tricks, and tag variants you haven't thought of yet. The robust pattern flips the question entirely. Stop trying to identify what's dangerous, and instead treat every piece of input as data, every time. Parameterize on the way in, encode on the way out. There's nothing left to bypass. Before we move on, a few beliefs worth dismantling. An ORM helps, but the moment you drop into raw queries or concatenate a string, you're back in injection territory. XSS isn't a pop-up nuisance. Once script runs in your user's session, the attacker effectively is that user, and front-end validation is just UX. Anyone can bypass the form and hit your endpoint directly. The real boundary is always server-side. So what does doing it well actually look like? Parameterize every query so input can never be parsed as code. Encode on output, match to the context, HTML, attribute, JavaScript, URL. Validate server-side with allow lists, not block lists, because enumerating bad characters is a game you lose. And layer on a content security policy as your safety net. On the other side, string-built queries, inner HTML with user data, and trusting the browser to police itself. Those are the patterns that keep showing up in postmortems. Now, the tooling around all of this. SQL Map will hammer your endpoints looking for SQL injection automatically, and OWASP, ZAP, or burp will sweep for injection and XSS more broadly. On the defensive side, parameterized APIs and ORMs handle the data versus code separation for you. DOM Purify sanitizes HTML safely in JavaScript. CSP headers shut the door on inline and foreign scripts, and a WAF catches known patterns at the edge. None of these replace the discipline, they reinforce it. So let's pull the threads together. Injection, at its core, is untrusted input being treated as code. SQLI crosses that line in your database. XSS crosses it in someone's browser. You fix the database side with parameterized queries, and the browser side by escaping on output and locking things down with a content security policy. And remember, encode everything, because block lists always leak. Somebody will find the character you forgot. If you remember nothing else from this talk, remember this one rule: never let data become code. Every defense we've covered, parameterize queries, output encoding, escaping, content security policies, is just a different way of enforcing the same boundary. Mix input and code, and the attacker ends up writing your logic for you. Keep them separate, and the nastiest payload in the world is just a harmless string sitting in a variable. If you want to keep going from here, there are two natural next steps. The Security Explained track walks through the rest of the OWASP top 10, the same way we approached injection today. Attacks first, defenses second, and if you work close to the database, the PostgreSQL hardening course takes parameterization, least privilege roles, and the rest of these patterns and turns them into something you actually run in production. Both live at dargslan.com courses. Before we wrap, I'm curious about your own war stories. Have you ever opened a file and found a select statement being built with string concatenation, user input dropped straight in? Maybe you fixed it quietly before anything happened, or maybe you caught a stored XSS hiding in a comment field. Drop it in the comments. These small finds are how most of us actually learn to take this class of bugs seriously. That's injection covered. The boundary between data and instructions, and the handful of patterns that keep it intact. Next in the security series, we move up the stack to authentication attacks, credential stuffing, session handling, token leaks, the whole layer above the query. If you want to follow along, subscribe and you'll find the rest of the material over at dargslan.com. Thanks for watching.